So we need to talk a little bit more about logging. So we know already that based on factory default settings, every device is going to have some logging enabled. More specifically, on our hard disk, or in most cases a solid state disk, some storage media within the device, we're going to have a messages file. Now that file could be called anything. Through our logging configuration, we can create any log file names we wish, but it's a free BSD convention that messages is a file name used to collect a lot of logging. Almost every system daemon on the box will have something to say at some point and log to the messages file with a default configuration. But there are other log files that are automatically created without any mention in the logging config. So if we log into config mode, dig down, edit into the system syslog hierarchy, we won't find any mention of a file chassis D or JDHCPD or various other file names that relate to system daemons. But those files are always there. If we go underneath the var log directory within the Unix file system, we'll see a whole host of logging that we didn't configure. So we can kind of say there's two different sets of log files, those that you explicitly name and those that, well, are there automatically because some system daemon is sending output to them. We think, or Juniper thinks, I guess, that stuff like chassis D, JDHCPD, there's some value to having it for troubleshooting, but we hope most of the time users don't need to look there. So those files are always there, probably for your reference when things go bad, you go to the TAC, or you're digging deeper into the lab as to what a system daemon is doing. So like I said, you can control through the logging config on the box exactly what logging happens. There's no reason why you don't take an event from RPD or DCD or whatever system daemon we might have listed here and log it once to one file and again to other files. A fairly common practice, for example, is to create a file named errors. We're going to pull all of our logging from many, many different system daemons into this messages file, but that's going to make it huge. It's going to be hard to read. There's going to be a lot of information in there, most of it, which is normal operation. It's just new to us when we look at it. It could be useful if we've created some other file, Phil's error file, errors, or whatever we decide to call it. And through our logging config, we filter the only really important, messages of, say, severity, error, or worse are actually logged to this file. If I'm an ops guy logging into the box and I want to quickly try and get a feel for what might be going wrong, if I type show log messages, I'm going to see tens of thousands of lines of output. A lot of it I might not be familiar with. If I do show log my error file name, well then I know everything there is something bad. Okay, it's something that maybe I should pay a bit more attention to. So that's interesting. We can log on the box, like we said. Most systems come with some internal media that's substantial in size, SSD or rotating media. But also maybe we want to have our logging config fire stuff off to a remote syslog server. Maybe we don't have one, maybe we have multiple for redundancy. But in my diagram, this router here, the blue block, that's our routing engine logging the events from these different daemons, and some of the events are maybe configured to actually be recorded to that syslog server. What does that really mean? Just like in Cisco, that's a UDP packet firing off to a syslog server somewhere to write it to disk. So now, even if this hard disk dies, even if the whole router goes up in smoke, I still have some offline record of what was happening on that device. I suppose the other thing we should mention, and we're not including in the diagram here, is there's a third form of logging. So we can also enable trace options in Juniper. We'll have a look at that later in the CLI. But trace options are a little bit different. It's really something that we're turning on because we're actively troubleshooting. We're debugging. Maybe we are having a problem with a new OSPF neighbor that won't come up, or a BGP session that's flapping. There would be a point at which maybe we considered enabling trace options, creating a file name on our storage media, and logging to it. Generally, though, we don't leave that trace option stuff on in production. Not a whole bunch of it anyway. I mean, there are some settings that are not really a risk to leave, with a certain level of detail in the trace options that won't impact the system. Maybe we want to record certain events for different protocol neighbors. But generally, we don't leave trace options enabled all over the system.